Hello. All right, today we are getting into transformations. This is going to be a introduction to transformations. This is going to be very important. Everything for first semester is going to come back to transformations, which we're going to be doing today and tomorrow, and then aspects of a graph. Those two key ideas are going to come up each unit. So it's important that you really focus on it and that don't kind of ignore it and be like, oh, it'll be over soon and we'll move on. This is something that's going to come up every single unit. And that's why we're going to spend so much time on it here in Unit 0, getting everybody caught up. Transformations is something that you did do last year in geometry. It is also something that you probably did in Algebra 1, but again, Unit 0, we're going to get everybody on the same page. Transformations, when you talked about that, you had translations and reflections and rotations and all that kind of stuff. We're going to be looking at a little bit of that, and we're going to talk about it how it changes our graph and how it changes our equation. So what we're going to start with is we're going to start with a parent function. And our first one, we're just going to start with the example of f of x equals x squared. The reason why we're going to start with this one is hopefully it's an equation that you're familiar with and it's a graph that you're familiar with. And if not, next unit, our entire unit is just going to be on quadratics, just on parabolas, just as on x squared. So we're going to get started with it now, focus on it now. Now it's called a parent function because it has no transformations. It's the most basic form of that function before you do anything to it. And there's some simple things that we can do to this graph. The first thing that we could do is we can move it up or down, and the way that we do that is we add a constant to the y value. So we see in yellowish here, that's your parent function. And this example, what we did here is that we took that and we moved the entire graph up. That's why our arrows are going up. And when we took our parent function, that parabola without any transformations, and we moved it up, we did that by adding a k value to the outside. Now notice it says when k is greater than 0, that means when it's positive, that means when you're adding, it moves the graph up. Now, if we had changed that k value to a negative number, for example, let's say we had made g of x equal to x squared minus k, that means we would have taken that parent function and moved it down. So moving it, shifting it, translating it up and down is going to happen by adding or subtracting a k value outside of that x squared. Now the next translation is when you can move it right or left. And when we move it left or right, we are changing the x value. Moving it up and down changes the y value. This one is a little bit more complicated. We see again that our parent function here is in this orange, gold, yellowish color. And we took that entire graph, and you see the arrows. We moved our graph to the left. Now when you move a graph to the left, that shift is actually happening inside of the parentheses that are being squared. The weird thing is, this is our general form of what happens. It's x minus h quantity squared. So in this example right here, we moved to the left. So what I did is I have a negative h value because I'm moving to the left, and we know minus a negative is actually going to make it look positive. So when you're looking at h and it's a plus sign, it's actually going to move to the left, and it only appears as though it's a plus sign because you subtracted a negative. When h appears to be negative, you're going to move the graph to the right. It always moves in the opposite way. Now this can be a little confusing because it's not, the h is positive, but it looks negative. So let's change this. So it looks positive and it looks negative. It's not that the actual H value is positive or negative, it's the fact that it looks like this looks negative and this looks positive. So I'm actually going to change that here. H is going to be less than 0 because the H value, like we said right here, is actually negative, but it looks positive. This is going to be greater than 0, so the H value is actually positive, it's just going to look negative. So horizontal shifting is always going to be the opposite of what it looks like. Alright, so we've moved our graph up and down. We've moved our graph left and right. The left and right one, this is the one that we always forget about. It's the opposite of what you see. Then we can change the shape of our graph. When we change the shape of our graph, we can stretch or compress it in the y direction. And when we call it in the y direction, that's a vertical stretch or vertical compression. There are horizontal stretching and horizontal shrinking, but we're not going to talk about it. We're only going to talk about vertical stretches and vertical compressions. And we do that by multiplying the entire function by a constant. So when your a value is greater than 1, not just positive, because positive negative is going to mean something completely different, but when it's bigger than 1, we're going to stretch it. So again, we see that gold graph, that's our parent function. When I vertically pull it, it's going to stretch it, making it skinnier. And we see that that a value has turned into a 2. So when that a value is bigger than 1, it's stretched. It's becoming a skinnier graph. Now we look at the next one. Sometimes we forget the whole thing. You just want to say less than 0. It's not less than 0. It's between 0 and 1. So it's that decimal or fraction between 0 and 1. When it's between 0 and 1, you are going to vertically shrink it or compress it. So same thing, we see that graph in yellow there, and we see our arrows going down because we're vertically pushing it down, and when we push it down, we make our graph wider. It gets fatter. So if it's a bigger a value, we're pulling it and stretching it, we're making it skinnier. If it's that decimal or fraction between 0 and 1, we're pushing it vertically down, making our graph wider. So again, our a value was 0.35. When you multiply that equation by that decimal between 0 and 1, we make it wider. Our last one is going to be a reflection. So we can reflect over the x-axis. There are reflections over the y-axis as well, but we will not be talking about those. We reflect over the y-axis when you multiply the entire equation by a negative. And that's why, in the last one, we said we don't talk about the positive negative aspect here, we're just looking at the number, because positive negative has to do with the reflection, not the shape. So if my a value was positive, it's going to be opening up if we're talking about a parabola. If my a value is negative, it was reflected. As we see here, here's my parent function, and then we flipped it, but we're not going to say flip. We're going to say reflection. We're going to make sure that we always use the proper vocab. We reflect over the x-axis, and we get our new graph. So if it's negative, it's a reflection. The number, whether it's positive or negative, determines the shape. So if it was a -2, it would be reflected, and it would be a vertical expansion. So positive, negative is one category. What the number actually is a separate category. All right, so that is just an intro of our transformations. More to come tomorrow. All done.